Morning students, I am NV Krishna Rao, Assistant Professor CSC Department. I am handling the compiler design for the 5th semester. So in today's class, we will discuss some of the examples for the deterministic finite automata. Right? So we'll discuss the examples for the deterministic finite automata. Here, what DFA says? DFA says that each state must have one and only one transition for each input symbol, right? It should have for each input symbol, right? So here, a DFA we represent as set of states, input alphabet, transition function, initial state, a set of final state, a 5-tuple notation. Right? A DFA we represent it with a 5-tuple notation. Q, a set of state, input alphabet, transition function, initial state, a set of final states. Right? So here, the state on each input symbol should have one and only one transition. It should not have 0. It should not have more 2 or more transition. Only 1 and 1. And for each symbol, it should have. So here, for our given problem is that construct a DFA starting with 0. It should start with 0, then 1. After that, it may have any number of zeros or ones. It doesn't bother. It should start with 0. Right. So what are the example strings for this 0, 1? Example strings are 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, so and so on. All these strings are starting with 0, 1. All these strings are starting with 0, 1. All these strings must be accept. All these strings must be accept. Other than these strings should not be accept. Other than these strings should not be accept. The starting symbol should be 0, 1. Right? They might be asked a question. The 0, 1 might be in middle anyway, or it should end with 0, 1, or it may ask. Right? So, the symbol sequence 0, 1 may start in middle or at the end. At different positions might be possible. Right? So, we'll check 0, 1. Okay? Now, we are considering our initial state as Q0. Q0 is our initial state. We are considering Q0 as an initial state. Right? What is the condition? 0, 1 must be starting symbols. So, Q0 on 0 must go to Q1. Q1 on 1 must go to Q2. It is a condition. It must starting with 0, 1. So, we must write 0, 1. Right? After 0, 1, 0, 1 is accepted. After 0, 1, any zeros are also accepted. Any ones also accepted. A sequence of zeros or ones or zeros also be accepted. Right? it must start with 0 and it should be followed by 1. After 0, 1, after 0, 1, any number of zeros are ones, are 0 and ones and zeros also be accepted. So also be accepted, right? Then, so on 0, 1, Q2 we consider as 0. So after going to Q2, any string, any symbols are accepted. So we considering as also as final state. So we consider Q2 as also as final state. Now, what DFA says? The DFA says a state on input symbols must have one and only one transition. So Q is a set of states. Till now we have determined Q0, Q1 and Q2 are the required states. We'll see what will be the final available states. Then, what is the input alphabet? The input alphabet is 0, 1. The input alphabet is 0. Now, Q0 on 0 we have determined it is going to Q1. Q0 on 0 is going to Q1. But Q0 on 1, where it has to go? Q0 on 1, where it has to go? A string is to be accepted only it is starting with 0 and 1. A string should be accepted if it is starting with 0, 1. If it is starting with 1 means not accepted. If a string starting with 101 is not accepted, 1011111, they are not accepted. 1010 not accepted. 1110 not accepted. Any string starting with 1 should not be accepted. So Q0 on 1 go to some other non-final state. It has to go to some other non-final state. After 1, Q3 on zeros or ones, it will be in the Q3 only, which are not accepted. Any string starting with 1, it should not be accepted. So Q0 on 1 going to Q3, a non-final state. So Q3 on zeros, on ones, it will not be accepted. It will not be accepted. So Q3 on zeros or ones, it will not be accepted. Right? Okay? Is it clear? Now, Q1. Q0 on 0 goes to Q1. Q0 on 0 goes to Q1. Q0 on 0 goes to Q1. Right? If it is followed by 1, it is accepted. But it is followed by 1 means the strings 0, 0. Is it acceptable? No. 0, 1 is an acceptable form. But 0, 0 not acceptable. So Q1 on 0 goes to Q3, a non-final state. After 2 zeros, any number of zeros or ones also not acceptable. Right? Any number of zeros or ones, it is not acceptable. Okay, is it clear? 0, Q0 follows 1, it is acceptable. But 0 followed by 0, not acceptable. So, Q1 on 0 goes to Q3. Then, any string, 2 zeros followed by 1 or 0, any string is not accepted. Because the DFA accepts only the string starting with 0. If it is a 0, 0, you should not accept. So, Q0 on 0 goes to Q1. Q1 on 0 goes to Q3. After that, any number of zeros are ones, ones and zeros, zeros and ones are not acceptable. Are not acceptable. Right? So here there are 4 states we require. Q0, Q1, Q2 and Q3. So these are the 4 states we require. Then what is the input alphabet? 0 and 1. Then we represent the transitions. The transitions are Q0 on 0 goes to Q1, Q0 on 1 goes to Q3, Q1 on 0 goes to Q3, Q1 on 1 goes to Q2. Okay. Then Q2 on 0 goes to Q2 only. Q2 on 1 goes to Q2 only. Then Q3 on 0 goes to Q3 only. Then Q3 on 1 goes to Q3 only. Right? These are the transitions. Then what is the initial state? The initial state we consider as Q0 only. What is the set of final state? The set of final state is Q2. Here in these 4 states, Q0, Q1, Q2, Q3. In these 4 states, Q2 is taken as final state. So our condition starting with 0, 1. Right? So Q0 on 0 goes to Q1. Q1 on 1 goes to Q2. Right? Q1 on 1 goes to Q2. So after 0, 1, any number of zeros and ones, it will be accepted. So any number of zeros and ones, it will be accepted. Okay. So we represented our problem with the 5 tuple notation: set of states, input alphabet, transitions, initial state, a set of final state. Now we have written the transition diagram, we have written the transitions, then transition table. Right? So the transition table. Now I am writing the transition table. What are the symbols? 0, 1. It is a transition. Then initial state Q0. Other states Q1, Q2, Q3. The final state represented with the asterisk. We are representing star before Q2. Then Q0 on 0, it is Q1. Q0 on 1, it is Q3. Q1 on 0, Q3. Q1 on 1 is Q2. Right? Then Q2 on 0, Q2. Q2 on 1 is Q2. Q3 on 0 is Q3. Q3 on 1 is Q3 only. So this is the resultant transition table, right? This is the resultant transition table. So whenever any problem is given to construct a DFA, we represent with the 5-tuple notation, then a transition diagram, then a transition table, then we write with the one example string for acceptance, one example string for not acceptance. So now till now we have constructed the 5-tuple notation, transition diagram, transition table. Now we'll check one example string for acceptance, one example string for not acceptance. Right? So we consider string transition function q naught on 0, 1, 1. Is it acceptable or not? We'll check. String transition function q naught on 0, 1, 1. Right. String transition q naught on 0, what it gives? Q1. Right? Q naught on 0 is giving resulting a state is Q1. Next input symbols 1, 1. String transition function Q1 on 1 followed by 1. Q1 on 1, what it gives? Q2. Right? Transition function Q2 state 1 is the input symbol. Remaining input symbol. Q1 on 1 is a Q2. Right? Transition function Q2 on 1. Transition function Q2 on 1. Transition function Q2 on 1. Q2 on 1 resulting a state Q2 which belongs to a set of final state, simply we say the string is accepted. After reading the symbols 0, 1, 0, after 0, 1, 1, it is reaching to a state Q2 which is a final state. Since it's resulting to the final state, simply we say the string is accepted. Okay? Simply we say the string is accepted. Okay? Now, we'll see one example for not acceptance. Q0 is the initial state. We take 1, 0, 1, 0. This string should not be accept. We'll check that one. String transition function Q0 on 1 followed by 0, 1, 0. What is a Q0 on 1? It is a Q3 followed by 0, 1, 0. Then Q3 on 0. Remaining symbols 1, 0. So Q3 on 0, what it gives? Q3 only. Remaining as 1, 0. Remaining as symbols as 1, 0. Right? Then Q3 transition function Q3 on 1 followed by 0. What is the Q3 on 1? It is Q3 only. So once again transition function Q3 on 0 which is Q3 only, which is not belongs to final state, which is not belongs to a set of final state. So the string is not accepted. So the string is not accepted. Okay, is it clear? So one string for acceptance, which is resulting to Q2 state. So it is accepted. Then we will see that another one Q3. So it is not accepted. Okay, Q3 simply it is not accepted. Okay, is it clear? One string accepted since it reaches the final state Q2 after reading the symbols input symbol 0 1 1. Another string 0 1 0 1 0 which results to the Q3 state which is a non-final state. So the string is not accepted. So whenever a problem is given to construct a DFA, we have to write 5 tuple notation, transition diagram, transition table, one example for acceptance, one example for not acceptance. Right? So we'll see one more example here. Construct a DFA starting with BA. Right? Starting with the sequence B followed by A only. If B followed by A only, then the string is accepted. Otherwise, the strings are not accepted. Okay. So acceptable strings, which are the acceptable strings? BA is accepted, BA is accepted, BA is accepted, BA is some A number of A's accepted, B A followed by some number of B's are also accepted. Which are not accepted? All 2A's, 2A's B, AB, which are not accepted. Here, these strings are accepted starting with B followed by A is accepted. If you say B comma B, also not accepted. BBA, also not accepted. Right? B followed by B followed by A. Also the strings are not accepted. Right? So here B followed by A, starting with B followed by A, only that strings are accepted. Any other strings starting with B followed by B or A followed by A or A followed by B also not accepted. So we represent finite automata with 5 tuple notation, right? Set of states, input alphabet, transition function, initial state, a set of final states. Okay? Set of states, input alphabet, transition function, initial state, a set of final states. Okay? Is it clear? Now, we consider what is the condition we have? The condition is starting with B followed by A. So, always we start with the initial state. Q0 is our initial state. On B, going to Q1 state, another state. Q1 on A goes to Q2 state. BA is accepted, means Q2 will be the final state. After BA, B followed by A followed by any number of A's accepted. Followed by any number of A's accepted. Or BA followed by any number of B's. BA followed by any number of b's also be accepted. Any number of b's also accepted. Simply we say Q2 on AB goes to Q2. Means first symbol B, after that A symbol, after that A's are B's, B's followed by A's are only B's, are only A's. All these strings are acceptable. So that is possible by considering Q2 is as a final state. By considering Q2 as a final state. Right? Is it clear? By considering Q2 is as final state. Now, Q0 is a state. On B, what the DFS says? Deterministic Finite Automata says a state must have one and only one transition on each input symbol. Right? On each input symbol. What are the input symbols we have? A comma B. There are two input symbols. There are two input symbols A comma B. Right? There are two input symbols A comma B. So Q0 on B goes to Q1, Q1 on A goes to Q2. Right? But Q0 on B, where it has to go? Q0 on B goes to Q1. That is acceptable. That is a condition it is reaching to a final state. But Q0 on A has to go another state Q3, which is a non-final state. Which is a non-final states Q3. So Q0 on A goes to Q3 state. Right? Now, what will be the transition Q3 on A or on B? That also be not accept. Any string starting with A should not be accept. Any string starting with A should not be accept. Right? So Q0 on A goes to Q3, non-final state. After that, A is also not acceptable. B is also not acceptable. Right? Q3 on A is also not acceptable. On B is also not acceptable. Okay, is over. Q0 on B we discussed. Q0 on A we discussed. Then Q1 state. Q1 on A goes to Q2. But Q1 on B, where it has to go? Q1 on B, where it has to go? So Q1 on B, it goes to Q3 state, a non-final state. The strings starting with BB also not acceptable. So Q0 on B goes to QA, Q1, Q1 on B goes to Q3, which are not acceptable. Right? So, which are not acceptable. Q0 on B goes to Q1, non-final state. Q1 on B goes to Q3, a non-final state. Says that it is not accepted. After that BB, any number of strings, any number of symbols, A's or B's also be not acceptable. So, this is the resultant transition diagram which shows that the strings accepted by starting with BA. Any other strings simply not accepted. Any other strings simply not accepted. Okay. Now, we have to represent a finite automata with the 5 tuple notation. Right? We have to represent with the 5 tuple notation. Right? Set of states. What are the states we have? Q0, Q1, Q2, Q3. These are the states. What is the input alphabet? The input alphabet is A comma B. The input alphabet is A comma B. Then transition functions. Then transition function. Transition function represent all the transitions in the finite automata. So Q naught on A goes to Q3. Q naught on B goes to Q1. Okay. Q1 on A. Q1 on A goes to Q2. Q1 on A goes to Q2. Right? Q1 on A goes to Q2. Q1 on B goes to Q3. Q3 on A goes to Q3. Q3 on B goes to Q3. What is the initial state we have? The initial state Q0 is Q0 only. What are the set of final state? The set of final state is Q2. Now we represented the given problem in this 5-tuple notation. Set of states, input alphabet, transition function, initial state, a set of final states. Okay? A set of final states. Okay? Is it clear? Now, we have written transition diagram and we have written the 5-tuple notation. Then we must write transition table also. The transition table which consists rows and columns representing the input symbols and states and its output transitions. Now we'll write the transition table for this given transition diagram. The transitions and transition diagram, transition table represent the same transition but in different forms. Now we'll see the transition table. This is a transition. What are the symbols? It is 0, 1, right? Initial state is Q0. The initial state is Q0. Q0 on A. Q0 on A goes to Q3 state. Goes to Q3 state. Q0 on B goes to Q1 state. Now we can say Q1 state. Q1 state on A. Q1 state on A goes to Q2 state. Q1 state on A goes to Q2 state. Q1 on B goes to Q3 state. Q1 on B goes to Q3 state. Right? Q1 on B going to Q3 state. Then what is the next state? Q2. Q2 on A goes to Q2 only. Q2 on B goes to Q2 only. Q2 on B goes to Q2 only. Right? So here Q2 is a final state. we represent as a cycle Q2 with a cycle or Q2 with a star. Q2 with a cycle or Q2 with a star. Then what is another state we have? Q3 state. The Q3 state on A, where it goes? It is Q3 only. On B, where it goes? Q3 state only. So Q0 is the initial state. We represent with the arrow as indicator as initial state. Q2 is the final state. It can be represented as a final state as a cycle, or simply using a star. Using the star representing the final state. Right? Representing a star or representing a cycle, it gives a final state. Right? Okay. Now, transition diagram, transition table, 5-tuple notation, we represent it for the given problem. Construct DFA starting with B. Now, we'll see one example string for acceptance, one example string for not acceptance. Right? String transition function, initial state, BAAB is the string is acceptable. Right? String transition function, Q not on B followed by AB. Right? What is the Q not on B? Q not on B goes to Q1. Q1 followed by AB. Q1 will have the input AB. Then string transition function, Q1 on A followed by AB. Q1 on A, where it goes? Q2. String transition function, this result is giving to Q2 followed by input symbols AB. Then transition function Q2 on A followed by B, which is giving a transition function. Q2 on A is Q2 only. Q2 on B is resulting the Q2 state, which belongs to a set of final state. So we are getting Q2 as a final state. After accepting the input symbols B, A, A, B, results to Q2 state, which is a final state. The string is accepted. Simply, the string is accepted. Now we'll see one example for not acceptance. Any string starting with BB is not accepted. String with BA acceptable. A with starting with A also not accepted. A not accept. AB not accepted. BB also not accepted. Now we'll see. By considering one example string for the not acceptance. So string transition function, Q0 is the initial state, B, A, B. We'll consider this string. So string transition function, Q0 on B followed by BAB. Q0 on B. What is the Q0 on B? It is a Q1. What is the remaining symbols? BAB. What is the remaining symbols? BAB. Then Q1 on B followed by AB. What is the Q1 on B? It going to Q3 state. It going to Q3 state. So output of the transition Q1 on B is Q3. Q3 input symbols are AB. Then string transition function Q3 on A followed by. What is the Q3 on A? String transition function Q3 on A will give Q3 only. Q3 on B, it gives Q3. So which is not a final state. Which is not a final state. Here, if we consider the input string BBAB, which results from Q0 initial state to a non-final state Q3. The Q3 is a non-final state, so simply we say the string is not accepted. So, if any problem is given, construct a DFA starting with BA. So, we write 5 tuple notation, a transition diagram, a transition table, one example for acceptance string, one example for not acceptance string. So which gives the complete solution for the given problem. Right? Is it clear? So this is a transition diagram, 5 tuple notation, transition table for constructing a DFA starting with B. So I'm giving one more problem. Practice this one. But what is this problem? Construct a DFA ending with 010. Construct a DFA ending with 010. So the previous problems we discussed where the string starts with some condition 01 or BA or with some starting symbols. We have specified the condition with starting symbols. But here the problem is construct DFA ending with 010. So practice this given problem, and I'm closing this section with this one. The example strings, example problems for deterministic finite automata. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.